Hello and good day, geometry. We are back now for CO4. In CO3, we covered the midpoint formula, finding the middle point of a segment. Now we're going to be interested in the next level, which is the distance of a segment. So here's our work for midpoint. I'm going to -4, -3, 2, 1. I can remember that. -4, -3, 2, 1. So we got the same segment that we had for C. What did I tell you? Drawing straight lines.
That's so straight.
No. But I missed the point. That's not good. I should, after 13 years of teaching, be able to connect two dots, you know? But there we go. Now it's, anyway. All right. So our next task here is to calculate the distance of the segment, which is not quite as easy, even with the coordinate plane, as locating the midpoint. Because unfortunately, since it's not horizontal or vertical, like if our segment was vertical, and I ask you for the distance of that segment, you can easily tell me that it's 2. Because on the x-axis, it goes from -4 to -2. That's clearly a distance of 2. If our line was vertical, segment, I keep saying line. If our segment's vertical, and I ask you for the length of that segment, you can easily tell me it's 3. You can just count. 1, 2, 3. Okay? But when it's diagonal like this, you can't just count across and say, well, it goes from -4 to +2, so this is a length of 6. Because going diagonally through a square is not a distance of 1. It's a little bit more than that, right? Diagonal line's a little bit longer than it's going across horizontally or vertically. So for this one, we have what's called the distance formula. The distance is the length of a segment pretty simple definition there, the length of a segment. The cousin to the distance formula is the Pythagorean Theorem. Have you worked with the Pythagorean Theorem before?
Yes.
Excellent. So you might remember some elements here. You might be thinking, well, okay. Well, no, I'm not going to go there yet. But you might recognize some elements here of the Pythagorean Theorem. Essentially, what we're finding is the hypotenuse of a right triangle, right? But there is a single formula that can be used, and it is the distance formula. So the distance of a segment D equals, you know, when the square root sign's that big, you're in for some fun times, right? You know that when it's that lengthy, yeah. Okay, the distance formula is, this time it's the difference of your x values squared. The difference of your x values squared. So again, we have x1 and x2 here, but we're subtracting them and then squaring that difference. Who said what?
Wait,
yeah.
So is it x1 minus x2 squared?
Yes. It's the difference. X1 minus x2 is in parentheses because we're finding the difference and squaring that. And then we're adding y1 minus y2. Oh, my root was a little bit too short. There. And we're squaring that. Okay? So the distance formula is x1 minus x2 squared, that difference squared, plus y1 minus y2 squared. Yes?
Do the exponents cancel out?
That's a great question. She just asked if our powers cancel out because of the root. In algebra, we have talked about how exponents and roots are opposites. What throws that off here? Why don't they cancel out? There's something in the formula that says, nope, you can't just cross them out because I'm here. Noah? No, not the parentheses. Nick? The addition. This addition sign here throws that whole thing off. Okay, so unfortunately, you can't just cross those out. Okay? All right. My caution here is remember your rules for adding and subtracting integers. Also, remember squaring will always yield a positive value, which means that since you're squaring, so even if x1 minus x2 is negative, when you square it, it'll end up being positive, right? Because a negative times a negative is a positive. Plus another positive. If you ever end up with a negative value inside of the root, you've done something wrong, because you cannot take the root of a negative number until algebra 2, when it becomes all of a sudden legal, okay? Except for your book number, exactly. So let's go back to our segment here. I'll write the formula up here so we've got a reference. We've got the square root of x1 minus x2 squared plus y1 minus y2 squared, and we're taking the root of all of that. So our endpoints, we've got -4, -3, and we've got 2, 1. Here's our x1 and our y1. Here's our x2 and our y2. Now it just becomes a matter of plugging it in and making sure your algebra works. You have a question?
Couldn't you just use like the rise over run as like lengths of a triangle?
Yes. You can use Pythagorean Theorem to solve this also. However, the distance formula, again, if you don't have a coordinate plane, you can't plot the points, and then this is where you would use it, right? So x1 minus x2, plugging these values in, we've got -4 minus 2, and we're squaring that. x1 minus x2, -4 minus 2. We're adding to that y1 minus y2, -3 minus 1, and we're squaring that. Our first set of parentheses here, -4 minus 2 is -6, and we're squaring that. Our second set of parentheses, -3 minus 1, is -4, and we're squaring that. -6 squared is what? +36. -4 squared is what? +16. So the distance of this segment is the square root of 36 plus 16, which is 52. Now you might be asking yourself, well, wait a minute, can't we just take the root of 36, which is 6, and add the root of 16, which is 4? 6 plus 4 is 10. Doesn't that work like that? No, math doesn't work like that. You need to do the addition within the root before taking the root of each piece. Yes?
You want us to do like one step at a time when we show our work?
As far as the work being shown, I don't want you to try and do this all in your head, but I don't need you to show every single step. I need you to show me something, okay? At the very least, I want you to show me this step, plugging the values in, and I want you to show me this step, kind of the end result. How much you show in between is up to you there, okay? I'm seeing a few scrunched faces, which either means you can't see or you're a little bit confuzzled about something. So if you are confuzzled or you can't see, well, but if you are confuzzled, please do ask. Yes?
So what would you use as your answer?
Your answer would be the root of 52. I mentioned earlier that as you get further into the maths, you'll use improper fractions more than mixed numbers. The further you get, you want to use exact values rather than estimations. Okay? Even though we just do CO2 in algebra, which was estimating the roots of non-perfect squares, which this would be about 7.1, 7.2. Okay, you should leave your answer in that form. Have you covered how to simplify square roots yet? Okay, so we'll leave that for a later date. So this would be an acceptable answer. Yes.
Are we allowed to use a calculator?
You are definitely allowed to use a calculator, because what's being assessed is not the computation, right? It's using the formula, which involves computation, yes, but you can use a calculator. All right, any questions on this before we go to another example? Okay, second example, back to our page here. It says find the distance between the 2 points, points A and points B. So again, if you want to identify your first X, your first Y, your second X, your second Y, and go ahead and plug them in to the formula. Which one do you want to do? I should ask you, which of these would you like to do? The first, second, or third? Colin? Second, fine. Lots of negatives there. That's not a bad choice. So again, we'll identify x1, y1, x2, and y2. Going to the formula, we have x1 minus x2, and it's topical that we covered PO3 today during class because our x1 value being positive 10 and our x2 value being negative 6, it does end up to be 10 minus negative 6. Okay? That subtraction sign being part of the formula has to be there. The negative sign belonging to our x2 value has to be there as well. So it is 10 minus negative 6. And we're adding to that y1 minus y2, which is negative 11 minus negative 20. It's almost as if I did that on purpose, just to make you practice that minus negative thing. So, our first set of parentheses, what is 10 minus negative 6? 16. And we're squaring that. And what is negative 11 minus negative 20? Negative 11 minus negative 20. Or negative 11 plus 20. 9. So we have 16 squared plus 9 squared which equals the square root of 256 plus 81, which gives us what? The square root of 337. Okay? Christopher.
Yeah, so that, you know how you did negative 11 minus negative 20?
Yep.
And the formula says, oh, never mind, I just wrote this wrong.
Okay. Any questions on this as you kind of just absorb it? Okay. Question? Yeah.
So the formula would be x1 minus y1 then? So you take. Oh, I get it.
X1, it's if your first x minus your second x, so 10 minus negative 6. Yep. Okay. Anyone still need these notes up here before I delete? Okay. So your homework, again, in addition to finishing those other two, which we can go over a second one before we leave if you'd like, but I just want to get through this. The real world, take a look at the landmarks you built in your town in CO3. So those 4 points, the library, the school, the church, and the city hall. Those 4 points, as mayor of this town, it is your job to construct sidewalks that connect all 4 buildings in a quadrilateral. So the general location, I don't remember exactly, but it was something like this, and then this one was over here, and this one was up here, something like that. So that's pretty good. Oh, wow. So you are building sidewalks Then I draw straight lines that look like kindergarten did it. You are building sidewalks that connect each of those 4 towns in such a shape. Okay? If each unit of sidewalk costs $65, how much of the town's budget will you be spending on sidewalk? So your job is to find the distance, right? The total distance of sidewalk needed. It's not that insane. I believe this point was, now I don't remember. 2.6, was that what it was? 3.6? This point was 3.6. This point was 0.8. You're to find this distance of sidewalk, you're using those 2 points and the distance formula to find the distance. Right? And then you have to do it for the school and the city hall and the church. The total distance of sidewalk needed. If each unit is $65, how much is that going to cost to connect all those sidewalks together? A lot is not an acceptable answer. Yes. Folks, shh. Go ahead. Sorry.
Then would you just add it all up and then?
Well, you have to be careful. I think I see where we're headed here. So let's just say, so don't write this down because it's not a correct answer, but let's just say for the distance between the library and the school, you get root 20, and then the distance between the school and the city hall, you get root 90. When you say add them all together, this would not equal the root of 110. Okay, so you can't add roots together such as that. In this case, either you use your calculator and you put root 20 plus root 90 and take whatever answer it gives you because your calculator knows how to do it correctly. We haven't covered this yet. Okay, or you would take the decimal value of this, which is approximately 4.5. You take the decimal value of this, which is approximately 9.5, I guess, and then add them together like that. Okay, so either way is fine, but don't add the roots together. Root 20 plus root 90 is not equal to root 110.
So 1 would equal a unit on the sidewalk, right?
Right. So to get the cost of this, it'd be 4.5 times 65. Okay.
Wait, so it would be 4.5 times 65.
Right. This would be 4.5 units of sidewalk.
And then
plus 9.5 units of sidewalk. So 4.5 times 65 plus 9.5 times 65. Yeah. So you're going back to your work in CO3, now finding the distance between all those towns, and then calculating the total cost. Yes? CO4? Okay. I can print one out for you. Whoops. Okay. Anyone like to see another example of the distance formula in action with one of these other 2 practice examples here? First or third? Go ahead. Third. Okay. So again, I highly recommend labeling your ordered pairs X1, Y1, X2, Y2. You're learning this for the first time. Don't cut corners yet, okay? And then go to the formula. The difference between your X values squared plus the difference of your Y values squared and the root of everything. So this one's going to be the square root of x1, which is -8, minus x2, which is 14. And here we don't have the minus negative thing going on because 14 is positive. This subtraction sign is part of the formula, so it's got to be there. Our second x is positive, so it's not minus -14 here. Here it's just minus 14. But we are squaring that, and we're adding to that y1 minus y2 Here it is minus -5 because we have the subtraction sign from the formula and the negative sign from the 5. Okay? Boys, simplifying a little bit further, -8 minus 14 is -22. We're squaring that. Plus 11 plus 5 is 16. And we're squaring that. A calculator note here. Whenever you square a negative number, it needs to be in parentheses. If you're putting -22 squared in your calculator like this versus with parentheses, you're going to get different answers. Okay? Because how order of operations works with your calculator, with parentheses, it will square -22. It will take -22 times -22, which is what you want. Without parentheses, it only squares 22 and then makes an answer negative. Okay? So when you square a negative number in your calculator, make sure you're putting parentheses around it so that it does it correctly. Positive numbers doesn't make a difference because there's no sign to take care of. Your calculator is a computer. It does exactly what you tell it to, and you have to make sure you're telling it to do the right thing. Yeah. Whenever someone comes up with a wrong answer and says, well, yeah, but my calculator told me it was. Well, your calculator did exactly what you told it to do. Okay? You told it to do the wrong thing. I take the side of the calculator. Sorry. Yeah. So -22 squared is what? 400 something? 484? Was that a guess or is that, I mean, it sounds right. 16 squared is 256. So we have the root of 484 plus 256, which gives us what?
7,465.
740.
Yeah, I'm just gonna wait till the square.
Okay. So the root of 740.
Yay.
Okay, so your homework for Monday, you've got the weekend to do it. I will assign Khan Academy tonight. That'll be due next Thursday. 2 of the assignments will cover the midpoint formula and the distance formula. We'll also get kind of the basic elements and the segment addition postulate. So things that we've covered so far. So Khan Academy will be more practice with that. But CO3 and CO4 due on Monday. Work with these formulas. Okay, you see me during the day multiple times. Some of you, if you have questions, I will answer geometry questions also. Yes. Well, I'm going to sign off first, and then I can come over there. So that's how you math, folks.